this starts our unit on trig functions, on graphing trig functions. 14.1. What do these look like? When we take the values from the unit circle and plot the points, what, for example, what you should be able to do, your objective is, if I say graph y equals sine of x, that you can do that without your unit circle. So let's see how we can make this as easy as possible. We want to graph it on the xy coordinate plane, so here's what that will look like. It's going to be longer on the, so label it xy so you know what we're looking at. This is like we're used to, we're plotting points, okay? And so we are going to do one period of each of these, and we haven't even talked about what that means. So one period means we're going to go until it starts to repeat itself, because then we just know it repeats. So we're going to graph one complete period. So let's start with 0 on the x-axis. This means when the angle is at 0 degrees. And we're going to, as we do this, we'll visualize the easy points on the unit circle are what we need. So let me point out that at 0 degrees, okay, so this is our unit circle. The key values are, remember the coordinates here. This should be easy to see in your head, 1, 0, because it's a unit circle, and this was 0, 1. What are the coordinates here? 0, -1, 0, right? Because from the origin, you move to the left 1, up 0. And what are the coordinates here? 0, -1, right? And in radians, this is 0 radians. How many radians at 90 degrees? Pi over 2. And here is, good. And this is, yep. And back to 2 pi, right? 0 or 2 pi radians. You know, the thing is, when you graph, you never see it, you don't, the x-axis is the angle in radians. And the y-axis, so the input, x, is the angle in radians. The output is the sine of the angle, whatever the sine of the angle is. So what are we focusing on, the x-coordinate or the y-coordinate? For sine. Sine is the y-coordinate. Remember on our unit circle at the top, you wrote cosine theta. Cosine is the x-coordinate, sine is the y-coordinate. Okay? So this is just review of your unit circle. So now we're gonna go around the circle once, and we're gonna plot each of these points over here and see what it looks like. So if x is 0, if we're at 0 radians, what's the y-coordinate? Right here, as we rotate around the circle, we're going to go around the circle. At 0, when the angle is 0 radians, what's the y-coordinate? Yeah, so 0, 0. So on the x-axis, we're going to go from 0 to 2 pi. Let me make this easier. Let's scale the x-axis. Going around the circle once, we're going to go from 0 to 2 pi, and then you go halfway is at pi, and then half of that is pi over 2, and half of this between 1 and 2 is 1.5, or 3 pi over 2. And the y values will go from 0 up to 1, 0 to -1, and back to 0. So see how it oscillates, 0 up to 1, 0, -1, 0. So we're just going to plot those points. The highest y value, the maximum, is 1. The minimum is -1. So the sign never goes outside of 1 or -1. It never gets bigger or smaller than 1 or -1. So let's just plot these points, and then you're going to see what the picture of sine looks like. So at 0, we have 0, yeah. At pi over 2, the y-coordinate becomes 1, so we're up here at 1. So we have a point here. Up here, at pi, the y-coordinate is 0. At 3 pi over 2, the y-coordinate is negative 1, and at 2 pi the y-coordinate is back to 0. Do you see how that's going to start again if we continued to go around and around and around the circle? So we get this sine wave. It looks like this. It looks like a sine wave. It oscillates up and down. And I'm going to put arrows on each end to show that if, it continues. It'll just go on and on like that forever. That's a sine wave. And that's where you get that oscillation, and you can, like if you have a sound wave or light waves or anything that follows, that's what a sine wave, the most basic form looks like. So you should be able to do this without looking at your unit circle, because you picture going around the unit circle, these key points that are easy to remember, right? It's not like I'm asking you to remember root 3 over 2 or anything like that. Those are in between, but they're in here. So you only need 5 points. 1, 2, 3, 4, 5, and then you sketch it. So let's do the same thing, and feel free to work ahead for cosine. Y equals cosine x. Now we're graphing the x coordinate as a function of the same. The x-axis looks exactly the same. So on the x-axis, a good way to start is to scale. So the process is go out to 2 pi, because that's one complete period around the unit circle, and then cut it in half a few times. So make a point plot somewhere that's halfway, and what do I label that? Pi. And then go half of each of those, and you'll have all 5 locations. So half of this is pi over 2. Yeah, and half of this is good. It's the same as it was before. Whenever you do a sine or cosine, you're gonna start with that. And what's the highest value of cosine is? And what's the minimum? What's the maximum value that cosine can take? 1, and the minimum is negative 1. Do you see how it's the same as sine, but it's just shifted a little bit? Because the values occur at different times. So let's start here at 0. At 0 radians, what is the x coordinate? 1. So we start at 1. If you get the starting place right, now the rest is pretty much easy, because then you go here, you go to 0 at pi over 2, the x coordinate is 0. There's only one place to go, it's down from there to negative 1, and sure enough at pi the x coordinate's negative 1. At 3 pi over 2 we go back to 0, and then we go back up to the highest point. So cosine, you have to just know the shape in your mind. It starts at the highest point and then it goes down from there. But the actual, everything else about it is the same. It's just shifted. It's actually shifted from sine, it's shifted to the left by pi over 2. So you can translate one to the other, actually. Okay, so the last one that looks for today, there's 6, right? There's 6 of them, but we'll stop here at tangent. It looks very different than sine and cosine, because it's calculated by dividing the sine value divided by the cosine. So it looks very different than this. So the way you set up, when you're asked to graph tangent, this will be a test objective. You'll just have to do this without your unit circle. Okay, we're gonna see what this tangent looks like, right? It's dividing the sine value over the cosine value. So let's, on our unit circle, let's put the tangents in. So what was the tangent at 0 degrees? 0 divided by 1? 0, good. What was the tangent at pi over 2? The tangent of pi over 2 is? It's undefined. What does that look like on a graph when something's undefined? We'll see in a second. What about at pi? Actually, what we're going to do is we're going to go the reverse way. What about at negative pi over 2 if I go this way? It's undefined again. When you graph one period of tangent, and this is related to, remember how I told you it's only defined in quadrant 1 and 4 for inverse tangent? You only go up this way and down this way. This is related to y. When you graph tangent, we're only going to graph one period going this way. We don't have to go all the way around the circle. That would be 2 periods. It would start to repeat itself. Yeah, because tangent over here is 0 again. So it would already start to repeat. So when you graph tangent, this is how you do it. You put your asymptotes in. That's what happens at an undefined location on a graph. So at pi over 2, we're going to go like this. You're going to label that pi over 2 and put a dotted vertical line called an asymptote. You have to know that word. Becomes, at the algebra 2 level, you have to know that. And then at negative pi over 2, we'll also put our asymptote. And then we're just going to plot 3 points. So we'll count that as 2 of the points that we're plotting, even though that means the graph can't touch those. Okay, but we're going to do 3 points in between. We'll label here, here. So this is going to be, what's half of pi over 2? Pi over 4, right? And this will be negative pi over 4. So let's go back to our unit circle. What was the tangent at pi over 4? That's an easy location to remember. At pi over 4, what's the tangent? When you divide sine over cosine, look on your unit circle. It's 1. That's an easy point to plot. And what is it at negative pi over 4? What's the tangent there? Negative 1. So those are really easy, and we need those points to see the shape of tangent. And so at pi over 4, so we're going to put 1 and negative 1. So we'll plot, at pi over 4, we'll plot 1. That's a key point. And at negative pi over 4, we'll plot negative 1. We need more than that. So far, it looks like 2 points, and that's it. What about at 0? What's the tangent of 0? At 0 degrees, sine over cosine is 0. So now we have 3 points. And I'll show you some websites that show you the values in between, but we don't need them to graph it. So it looks like this. This is what tangent looks like. We only need 3 points. As long as you kind of know what you're expecting. The tangent increases from pi over 4. It increases all the way up until it becomes so large that it's undefined. It goes to infinity. So in the unit circle, it increases and it goes to infinity. And in the other direction, it goes to negative infinity. It gets smaller and smaller and smaller. And so we just you have to put arrows on the end. You need to graph the 2 asymptotes and these 3 specific points. And that's 1 period of tangent. Now, if we want to, we can repeat any of these. We would just go out another, the same distance. We would just repeat the same thing if we wanted to do another period. In fact, let's do that for tangent, just to show you that it's not that bad. So the length of the period here for tangent is, what is this distance? From negative pi over 2 to pi over 2. Pi. So the period, let's write this. The period for sine, the amount of time it takes to repeat, is 2 pi. You have to go all the way around the circle. The period for cosine is also 2 pi. But the period for sine is just pi. It's different. So you do need to know that. So we're going to repeat the same thing. So we're going to add, what's pi plus pi over 2? 1 plus a half is 3 pi over 2. So we're going to go out another period, 3 pi over 2. And we're going to put an asymptote there. The tangent would be undefined at 3 pi over 2. I'm just showing you how to repeat if you're asked to graph more than 1 period. So then the middle location between these two is you would add them up and divide by 2. That's 4 pi over 2 divided by 2 is 2 pi. So the middle would be 2 pi. That's just the halfway between a half and 3 halves. Oh no, 4 halves. It would be just pi. Yes. would be just pi. You add them up and divide by 2, that's just pi. And so now without doing anything else, because I see the pattern over here, I know it's going to be 0 here. And sure enough, yes, tangent is 0 at pi. And I know it's going to go up to 1 here, and it's going to go down to -1 here. And so I can just draw the shape in again. And I could go on and on and on, right? It goes on and on both directions. You could do 3 periods or 4 periods. So sometimes I'll ask you to graph 1 period or 2 periods. Okay, and you're just using the key values on the unit circle. Like 0, 1, undefined, and -1. 0, yeah, so you want to memorize, you should be able to picture that on the unit circle.